Okay, good day viewers. You're welcome to Chemistry Tutor. Now, on today's video lesson, we'll be talking about organic chemistry. Now, the first thing, we'll define organic chemistry. Organic chemistry is defined as the chemistry of carbon compounds. Now, we have other carbon compounds. We have this is a carbon compound. We also have this is a carbon compound. We have this is a carbon compound. Now, but organic chemistry does not talk about the inorganic compounds of carbon, like the calcium triisocarbonates 4, the hydrogen triisocarbonates 4. So, the organic, we can also say that organic chemistry is the chemistry of carbon compounds, except the compounds of calcium triisocarbonates 4, hydrogen triisocarbonates 4, or any inorganic compounds of carbon. Now, what are organic compounds? Organic compounds are compounds in which carbon, hydrogen, and oxygen is usually present. Phosphorus, sulfur, and nitrogen are sometimes present. So we said organic compounds are compounds in which carbon, hydrogen, and oxygen are usually present. Phosphorus, sulfur, and nitrogen are sometimes present. Now, let's talk about the characteristics of organic compounds. Number one characteristic is they are covalent in nature. They are covalent in nature. Now, on our video lesson, we talked about covalent bonds. And we said covalent bonds, they are bonds that are made up of compounds. These are bonds formed by the sharing of electrons. So, in organic compounds, they share electrons, so they are covalent in nature. Number two, they are usually non-metals. They are usually non-metals. Number three, they bond exothermically. In the presence of plentiful supply of air. In the presence of plentiful supply of air to form carbon dioxide and water. So we can have a formula like this: CXHY plus X, open bracket, XY, X plus Y over 4, all brackets, O2 equal to XCO2 plus Y over 2H2O. So I said they bond exothermically in the presence of plentiful supply of air to form carbon dioxide and water, and in limited supply of air to form carbon dioxide and water. Now, organic compounds in plentiful supply of air they form carbon dioxide and water, while in limited supply of air they form carbon dioxide, which is CO2, it's just CO, and water. Number three, they are, number four, they usually decompose easily on heating. They usually decompose easily on heating. Or we can say they are highly inflammable. Okay, now number 5 is they are soluble. They are soluble in non-polar solvents. Non-polar solvents, except the compound containing the hydroxyl group. Except the compound containing the hydroxyl group, that is the OH group. Okay. Now, the next thing we'll move on to is the homologous series. Now, homologous series are families of organic compounds which follows a regular structural pattern in which each successive member differs in their molecular formula by a CH2 group. I said homologous series are families of organic compounds which follows a regular structural pattern in which each successive member differs in their molecular formula by a CH2 group. Now, we have the homologous series. We have here we have the homologous series. We have the structural formula, and we have the functional group. So here we have the alkanes. The alkanes, they have a single bond. We have the alloalkanes. The alloalkanes, they are formed when halogens combines with alkane. So you have something like this. This is their functional group. This is any halogen. It can be bromine, iodine, fluorine. So this is any halogen. We have the alkene. The alkene, they are double bond. We have the alkyne. The alkyne, they are triple bond. We have the alkanol. Here we have the ROOH. Now the RO means any alkyl group. The RO is any alkyl group, which I'm going to talk about. So we have the next one, the alkanal. Here we have so we have the CHO. This is the alkanal. Here we have the alkanoic. Here we have the alkanon. Alkanon, they also known as the ketones. We have alkanoids. The alkanoid, they also known as esters. Here we have the RCO. Here we have O, and also any alkyl group. we have the primary amine, we have the amides, we have the nitrites, and we have the ether. Now, all of these, they are homologous series. Now, each member is called an homolog. Each member is called an homolog. Now, properties of homologous series. Number one, they have the same method of preparation. Number two, they have the same general molecular formula. Number three, each successive member differs in their molecular formula by a CH2 group. By a CH2 group, and their relative molecular mass increases by 14. Now, let's explain. We have 12 here. We have 12. Carbon is 12 plus 2 times 1, H is 1. So if you add this is what? 14. So each successive member differs in their molecular formula by a CH2 group. So their molecular mass will increase by 14. Okay, now we also have the next one. I said number one, number two. Now number three or number four. Their physical properties increases as the number of carbon atoms increases. That means from alkane we have the alkane, methane, ethane, propane, butane. They are gas. From pentane to hexane to decane, they are liquids, while from decane till down the road they are solids. So their physical properties differ as the number of carbon atoms increases. Now let's talk about the functional group.